Okay, today's lesson is absolute value inequalities. They're almost like absolute value equations. It's just now we have an inequality symbol instead of an equal sign. So the steps are the same. You are going to isolate the absolute value expression. And then you're going to write your two cases, a positive and negative case. When you have the positive case, nothing happens to the symbol. It stays the same. But for your negative case, you have to reverse the symbol. So kind of like when you divided by negatives, you have to reverse the symbol. In other words, flip it over. And another thing you want to make sure you remember with absolute values, did we ever distribute? No, we never, ever, ever. So the same is true for inequalities. Okay, we're not going to distribute. Okay, so example 1. We have the absolute value of x, and then outside the absolute value bars we have minus 3 is less than negative 1. So we're going to isolate the absolute value expression, so I need to add 3 to both sides. Now I have the absolute value of x is less than 2, so I write my positive and negative cases. Either x is less than 2, and then the other possibility is x is greater than negative 2. I flipped the symbol around for the negative case. I'm going to graph it so I can figure out if it's an and or an or. Well, let's find out. X is greater than, no, x is less than 2. So I'm starting at the 2 and I'm going that direction. X is greater than negative 2 would be an open circle, negative 2 going that way. So since it goes together, it's an and. Okay, let's do one more example, and then I'm going to have you guys do one on your whiteboards. All right, so example 2, I've got 2 times the absolute value of x is less than or equal to 6. So for this one, I have to divide, because I'm not going to distribute into an absolute value. When I divide both sides by 2, I get that the absolute value of x is less than or equal to 3. And so writing the positive and negative cases, I've got x is less than or equal to 3, and I have x is greater than or equal to negative 3. So this time I have closed circles. X is less than or equal to 3. I put it on the positive 3 and go that way. Greater than or equal to negative 3 would be going the opposite way. So they're moving towards each other. This one is also an and problem. If I graphed it and they were going opposite each other, what word would it be? It would be or. So sometimes you need to do the graph before you can figure out which one it is. All right, so on your whiteboards, you guys are going to do the absolute value of x, and then outside the absolute value of plus 2 is greater than or equal to 8. So graph it before you decide if it's an and or an or. Okay, so it looks like most of you guys are getting it. You subtracted 2 from both sides, and then you had that the absolute value of x was greater than or equal to 6. So x is greater than or equal to 6. X is less than or equal to negative 6. When you graph that one, you have closed circles, and they're going the opposite way, so it's or. Okay, let's take a look at example 3. This one's for your notes. All right, so again, I need to isolate the absolute value expression first. So I'm going to add the 1/2 to both sides. Subtract the 1/2 rather from both sides. Then I have the absolute value of x plus 2.5 is greater than or equal to 3.5. And so now I write my positive and my negative case. X plus 2.5 is greater than or equal to 3.5. My negative case, x plus 2.5 is less than or equal to negative 3.5. I subtract 2.5 from both sides on both of them. And I get x is greater than or equal to 1. And on this one, I get x is less than or equal to negative 6. So x is greater than or equal to 1. I have a closed circle going to the right. Less than or equal to negative 6. I have a closed circle going to the left. So this one is an or. X is greater than or equal to 1, or x is less than negative 6. Less than or equal to negative 6. Okay. This next one, actually, let's turn that sign around. I want to have you guys do it less than or equal to. So, and you're going to do it on your whiteboards. So the absolute value of x minus 8, and then outside of that you have plus 5, is less than or equal to 11. Okay, so you would have subtracted 5 from both sides, and then you get x minus 8. The absolute value of it is less than or equal to 6. So you write your positive and negative cases, add 8. You got x is less than or equal to 14, and x is greater than or equal to 2. That's what your graph looks like. So is it an and or an or? What is it? An and. Yes, it doesn't look like the oars of a boat. All right, now sometimes we have special cases. When an absolute value is compared to 0 or a negative number, that is a special case. When we compare it to 0 or a negative number. If the resulting expression is true, just like before, it's all real numbers. If the resulting expression is false, it's no solution. So what that looks like is, for a true situation, absolute value is always going to be a positive number, right? And if it is greater than or equal to either a negative number or 0, okay, is a positive number going to be greater than or equal to a negative number? Is a positive number greater than or equal to a negative number? Yes, it is. Is a positive number greater than or equal to 0? Yes, it is. So if that's the situation you end up with, it's all real numbers. But if you end up with the absolute value less than or equal to a negative number, or 0, a positive number can't be less than a negative number, can it? And a positive number can't be less than 0, so it would have to be no solution. All right, so let's take a look at a couple examples and see what happens. On example 1, I have the absolute value of x plus 4, and then outside the absolute value bar is minus 5 is greater than negative 8. So just like before, I want to isolate my absolute value expression by adding 5 to both sides. Then I have the absolute value of x plus 4 is greater than negative 3. Now, whenever you see a negative number opposite your absolute value, that should be setting off alarm bells in your head. Oh, wait, this is a special case. So again, this is a positive number, right? This is a negative number. Is a positive number greater than a negative number? Yes, it is. So this would be all real numbers. Right, you don't have to go any further because the negative number. So these problems actually are quicker than the regular ones. All right, let's take a look at another example. I've got the absolute value of x plus 2 plus 9 is less than 7. So, x minus 2, excuse me. So I subtract 9 from both sides. And now I have the absolute value of x minus 2 is less than negative 2. So this time I've got a positive number less than a negative number. Can a positive number ever be less than a negative number? No, it can't. So this one is no solution. So let's see. I'm going to have you guys do this one on your whiteboards. Let's see which one of those cases this one will be. Are we going to distribute? No, never distribute. Okay, so we ended up with a positive number being less than or equal to a negative number. Is that possible? No, so that one was no solution. Okay, one more problem to try on the whiteboards. We've got the absolute value of 2x plus 9 is greater than or equal to 9. So you need to add 9 to both sides. Subtract 9 from both sides, rather. Then you get the absolute value of 2x is greater than or equal to 0. That's a positive number. Greater than or equal to 0. And that is a true statement. Therefore, it's all real numbers. This concludes the video.